Okay, so I've gone ahead and generated a whole bunch of dummy data, and I'm just going to clear my workspace. Okay, so I've got all these dummy data, and I'm going to use them to demonstrate the different types of joins. Okay, so we've got a whole bunch of workers, and a whole bunch of managers, and a whole bunch of regions. We've got some start dates and an end date, and then what's happening here is I'm using this function to generate a sequence of dates from the start and end, but then I'm also doing something else afterwards. And you might remember how I said the dot represents the data above. So here I'm using the base R syntax to filter out the 7th, 8th, 9th, 10th, 11th, 12th, 13th, and 14th dates in this date range. Okay, so the reason for this will become clear in a second. Okay, so if I run this, and then because I'm using random data, I'm going to set a seed. I've got sales by workers, workers and managers and regions table. So what these have is the sales for each day by each worker. Then I've got the which manager each worker is assigned to. And then I've got which region each manager is assigned to. Okay, so one of the first things to cover might be if we look at sales, we could left join the sales data with the workers as manager. Okay, so inside sales, we've got workers column. Maybe we might like to call it worker, because the vector can be workers plural, but generally in column names it's better to have it singular. So here we go, so worker, and then we've got worker and manager. So we can join on worker, whoops, by worker left, whoops, left join. There we are. So now for Adrianette, we know that her manager is Tracy, and that should be matched up here. Adrianette, Tracy. Good. So it's joined, and we can only see the first worker because all her days are like that. But if we wanted to, we could arrange by date, and then we'd see multiple different people. Yep. So Nolan is Marissa. Just double check. Nolan, Marissa, good. When the columns do not match, so for example, if we had called it workers as before, this would no longer work because it cannot find the corresponding column name. So what you do is you have to wrap the join inside a combination. Okay, so in this case here, the left side is workers, and that equals worker. Oops. And I've got to forget to close off that so we can add it in there. Oops. Let's try one more time. Yeah. So that's worked fine. So that's what you get if you have different names. Now, and you can also, join on multiple different fields. So some other field equals some other field, but just got to make sure that the field name is wrapped in quotations, because what this actually is a named vector. Okay, so that actually can be useful. Named vector. Sometimes it's useful, and I think you do it like this. I think you can go 1, 2, or else it's the other way around. No, other way around. 1 and 2. So in this case here, the value is 1 and 2, but the names of the values are, like so. So it can be quite useful, because then you can pull out the values. Yeah. So you can, if we go that times 5, yeah. So it's multiplied it. Yeah. Just useful to know. So that's how you do a left join. Very, very useful. If we go back a step, we might check out this right join. Okay, so with all the sales that are happening, there's a whole heap of sales, and we know what the minimum date is. So let's, if we pull that out, so minimum of sales date. Okay, and then let's get the max while we're there. Max. Okay, so let's get a sequence dot date, doing a similar thing to what we did before. Okay, and let's just call this tip. Okay, so we've got a whole range of dates. Now, what we might do is we might right join that tibble all dates. If we wanted to, we could, well, let's do something else. Let's do this. Let's do a anti-join with all dates. Okay, so it worked. So it was looking for any dates in sales that were not in all dates. Okay, and we didn't need to supply the joining column because it just there was one column that it was the same, so it just said date it is. If we go around the other way and run that, we see there are 7 or 8 dates that are present in all dates but not in sales by workers. And that's because we filtered it earlier on, and so that's what an anti-join does. A semi-join, oops, double. So a semi-join is just seeing which dates are the same. So yeah, which dates are in both. Good, okay. You might also want to use a right join. So if we take in all the sales by workers, and we know there are 8 days missing, and we right join with all dates, this was fine, it was happy, because it joined on date, which was a common column. But if we go ahead and filter is.na total sales, we can see those are the missing dates. So if there are missing values in your table and you want to populate, that's one way to go about doing it. If we had additional dates, and let's say in our all dates thing here, and we could produce that by adding a whole week to the maxed date value, we could actually do something called the outer join. Oh no, full join, sorry, full join. And now filter is.na date. Oh no, total sales, sorry. So now we've got a whole heap of extra. So we've got the ones that were missing in the total sales thing, but we've also got the additional dates that were present inside the all dates sequence. Okay, so that's covered quite a lot. Left joins, right joins, full joins, semi-joins, and anti-joins. A very critical thing to know about with data manipulation. The other critical thing to know about is when you are joining 2 tables together, if it's a many-to-one relationship, generally you're okay because you're just adding another column. But if you've got a many-to-many relationship, you can expand your data set too much. And what I'm talking about here is if we were trying to join, if we're trying to find out how much sales were occurring in the regions, we wouldn't be able to do this because when we left join to the workers and managers table, like so, Whoop. Yep, when we left join like that, if we join again to the managers and regions table, manager, I think it is, yep. If you look at the managers and regions table, you will see that Marissa and Torrance both look after 2 different regions. So yeah, so that would expand the data frame. So there would be duplications. If you look here, we can go 1716 rows, and if we go distinct, distinct. Ah, yeah, because of the region is on there. Yep. So if we took out 716, yeah. So there's amplification of our data. So that's something to watch out for. Okay, I think I'll stop that one right there.